Assalamu alaikum and welcome to Mathcast with Faria Yusuf, and this video is regarding the graphs of trigonometric functions. And in this video we shall be discussing the graphs of sine and the cosine function. So graph of sine function. So for the graph of sine function, we should be knowing the axes values, which means I should be considering all the angles as 0 degrees or 0 radian, 90 degrees or pi by 2 radian, 180 degrees or pi radian, 270 degrees or 3 pi by 2 radian, 360 degrees or 2 pi radian here. And on these axes, we know that sine of 0 is a 0, sine of 90 is a 1, sine of pi by 2 is also a 1, sine of 180 or pi is a 0, sine of 270 or 3 pi by 2 is a negative 1, and sine of 360 or 2 pi is a 0 value here. And from these values, I can see that the sine x ranges from negative 1 lesser or equal to sine of x lesser or equal to 1, meaning this is going to be the range of the sine function. So if we have discussed earlier also that for sine of x, if your sine is less than negative 1 or greater than 1, then the sine function is not possible. So here we have come to certain conclusions, and the conclusions are that any angle outside 360 degrees has an equivalent angle in the interval 0 to 360 degrees, meaning if it's the second rotation and we have an angle of 405 degrees, then it shall be equivalent to 45 degrees, or we can say it's 405 minus 360, which shall be equal to 45 degrees here, and an angle of negative 122 degrees. So negative 122 degrees means we are talking about clockwise rotation. We are talking about clockwise rotation, and that shall be equivalent to an angle of 240 degrees. So if this is the axis that we have shown over here, then negative 122 degrees means it's the clockwise rotation, negative 120 degrees, and this then is equivalent to anti-clockwise positive 240 degrees here. And for the first one, we know that if these are the axes, then 405 degrees, it's the second rotation angle. Therefore, 405 degrees, 360 plus 45, 405 degrees, then shall be equal to a 45 degrees here. So these are the two conclusions that we should be having over here. And with respect to the axis angle values for sine of x, if I just sketch a graph, a basic sine of x graph, then what I come to know here is that for sine of 0, it's a 0, sine of 90 or a pi by 2, it's a 1, sine of 180 degrees or a pi is a 0, 270 degrees or 3 pi by 2, our sine value is a negative 1, and 360 is a 0. Meaning, after sketching all these points with respect to the values that I have shown in the table, I can see that the sine graph or the sine curve goes like this. It's a wave over here that I should be following. I should be having a wave, a complete wave, a complete rotation for sine of x, which goes this way. So again, if we look at the sine graph here, then what I shall be seeing here is that if it is sine of minus x meaning it's the clockwise negative angles that we shall be having. So what I can see here is that sine of minus x equals negative sine of x. Negative sine of x meaning 0 to 180. I can see that all the sine values, they are positive. Sine values from 0 to 180 degrees, they are positive. But if I go from negative 180 till 0, it's the same curve, but it's just that the sine values, they are all negative here. Sine of 180 to 360 degrees, all the sine values, they are negative. But if I consider sine of negative 360 degrees up till negative 180 degrees, They are the same, but just with the opposite sign as a positive here, negative and a positive. So this gives us the conclusion or the identity that sine of minus x, which equals negative sine of x degrees or radian values. In the second quadrant meaning from 90 till 180 degrees, 90 till 180 degrees, what we see here is that in the second quadrant from 90 to 180 degrees, all the sine values, they are positive. Therefore, sine of 180 minus x shall be equal to sine of x. Third quadrant, sine of 180 plus x, third quadrant from 180 till 270 degrees, all the sine values, they are just negative. Therefore, I'm just going to say that sine of 180 plus x shall be equal to negative sine of x. The values are the same, it's just that the sign will be a negative here. Sine of 360 minus x, meaning we are talking about the fourth quadrant from 270 to 360 degrees, and again the sine curve is a negative, has negative values. Therefore, the sign which should be assigned to the sine curve should be a negative here. So sine of 360 minus x shall be equal to negative sine of x. If it's the rotation which is after the first rotation, then it's the same curve which is getting followed. It's the same curve which gets followed for the second rotation here. So we can say it's sine of 360 plus x, which equals sine of x, and this is what we have discussed earlier, that any angle outside 360 has an equivalent angle in the interval 0 to 360 degrees. For example, we discuss 405 degrees, which shall be equal to 45 degrees. Or if I say it's a 420 degrees, then 420 degrees shall be equal to 420 minus 360, which shall be equal to 60 degrees. So 420 degrees shall be equal to 60 degrees there. So we have seen it over here that after 360, it's the same curve which gets followed. Therefore, the angles are going to be equivalent to the angles in the first rotation here. So these are the basics of the sine graph that we shall be knowing, and I will recommend all my students to be knowing these values, the axes values for sine of x on the fingertips, so that the graphs can be sketched easily and quickly. We have to save time, therefore, while doing the paper. Therefore, all the students, they should be knowing these axes values for sine on their fingertips. And it's not even difficult. Sine of x is 0, 1, 0, negative 1, and 0. Now let's do some composite graphs. Number 1, it's the graph of y equals a sine of x. We can see that we have this a over here. Initially, if we were doing the graphs, we were doing the graph of y equals sine of x. So this means y equals sine of x, that the coefficient of sine x was a 1, and that is why we said that the sine graph was ranging between negative 1 and 1 here. But then if there is y equals a sine graph and it has a period of 360 degrees, then we should know that this a is actually the stretch factor. This a is the stretch factor, and we can say that it is the stretch by factor a, which is parallel to the y-axis. And the range of values for y equals a sine x then is going to be negative a lesser or equal to y lesser or equal to a. Now this means that if we have the basic sine graph, this is the basic sine graph y equals sine of x in blue, then with y equals a sine of x, we can say that it's the stretch along the y-axis, parallel to the y-axis, with the stretch factor a, so that now I can see that when sine of 90 was a 1, it should be 1 times a, giving me sine of 90, which equals to a here. So if I substitute x with 90, then sine of 90 will be a 1, and 1 multiplied by a shall be a 1, and I should be having sine of 90, which then will be equal to a. Similarly, if I talk about sine of 270, then sine of 270 degrees equals a negative 1. Sine 270, if I substitute x by 270, then sine of 270 is a negative 1, and negative 1 multiplies by a gives me a negative a. So I can see that the original graph has been stretched parallel to the x-axis, to the y-axis, from 1 till a, from negative 1 till negative a, and now I can say that the range of the graph is from negative a up till positive a. So this is the composite graph for y equals a sine x, which is actually the stretch by factor a parallel to the y-axis. Let's do an example. Sketch the graph of y equals 2 sine of x. So y equals 2 sine of x, I have already sketched or marked the values for sine of 0, which is a 0, sine of 90, which is a 1, sine of 180, a 0, sine of 270, a negative 1, and a 360, which is a 0 again. So I have marked the original values for y equals sine of x, y equals sine of x. But now if the graph says that it is y equals 2 sine of x, so I should know that this 2 is actually the stretch which is parallel to the y-axis, and my graph now should range from negative 2 lesser or equal to y, which is lesser or equal to 2. So let's start doing the work. So what I can see here is that sine of 0 is a 0, 0 multiplied by 2. I'll do the working, some of the working here. When x equals 0 degrees, then sine of 0 is equal to a 0. Therefore, y then shall be equal to 2 times 0, which gives me a 0. So meaning there is no change in the y-axis, in the y coordinate here. If my x is a 90 degrees, then I know sine of 90 equals a 1. Therefore, y then shall be equal to 2 times 1, giving me a 2. If x is 180, then it's sine of 180, which is equals to a 0. Therefore, y then should be 2 times 0, giving me a 0. And if our x is a 270, then sine of 270 is a minus 1. Therefore, y should be equal to 2 times negative 1, which gives me a negative 2. And if x equals 360, then sine of 360 equals a 0, giving us y, which is equals to 2 times 0. That should be equal to a 0 here. So this means if I sketch all these values that I already have taken out, then I can see here that x is a 0, the value remains a 0. If x is a 90, then it has stretched parallel to the y-axis by 2. 180 degrees giving us a 0, 270 stretched by negative 2, and 360 is a 0. So I can see that this graph is shall be going like this. So this then is the graph of y equals to sine of x, which is the stretch parallel to the y-axis. So the next case is for the graph of y equals sine bx. So what the difference that I see here is with respect to the b, which is getting multiplied by the angle. So whenever we have this b here, then we should know that it's a stretch of y equals sine of x factor 1 by b. We have all done this in function transformation. With x, it should be a factor 1 by b, and it's a stretch parallel to the x-axis. It's a stretch parallel to the x-axis. Now, sine function has a period of 360 degrees. So here I should say that the period then will be squeezed by 360 divided by b, whatever the value of b is. It should get divided by b, and then we should be making the graph of the sine bx function. So it is a stretch of y equals sine of x factor 1 by b, and it's parallel to the x-axis, and the range of y equals sine bx is negative 1 till 1, because it's just a stretch which is with respect to the x-axis, parallel to the x-axis, so the range is not going to get affected here. It will be -1 till 1. So let's do an example. If I sketch y equals sine 2x for 0 degrees lesser or equal to x lesser or equal to 360 degrees. Now, we know that if we have sine of 2x, then it means that this sine function is getting rotated twice. There are two rotations with respect to this b value, which is a 2 here. So two rotations, and it should be plotted, it should be sketched for 0 to 360 degrees. And we know that the period of sine, that the sine period is 360 degrees. Period of sine equals 360 degrees, meaning the sine function gets a complete rotation in 360 degrees. So if it says it's y equals sine 2x, then I should be dividing it by this value of b, which is a 2 in this case, and this period then gets squeezed by 180 degrees, meaning it's the first cycle for the sine function. It's the first cycle for the sine function, which should be in the domain of 0 till 180 degrees, and we can plot or sketch the second cycle from 180 degrees till 360 degrees. So that is why I used the word squeezed, and it meant that in 360 degrees I will be making two cycles, the first cycle from 0 to 180 degrees and the second one from 180 till 360 degrees. So let's sketch the graph. A whole cycle requires four quadrants, all the four quadrants. A whole cycle of 360 degrees requires all the four quadrants. So now if the first cycle gets completed from 0 to 180 degrees, then it means that in this domain 0 to 180 degrees, I shall be getting all my four quadrants here. So if I divide it by 4, then the value that I should be having here is going to be a 45 degrees here. So 45 degrees each, the cycle gets completed, meaning if x will be equal to 0, then plus 45 degrees, 45 plus 45 giving me a 90 degrees, 90 plus 45 giving me 135 degrees, and then 135 plus 45 giving us 180 degrees. So these are the x values that I should be having on my axes here. So 2x then shall be equal to 2 times 0 a 0, 2 times 45 a 90, 2 times 90 a 180, and 2 times 135 at 270, and 2 times 180 giving me a 360 degrees. So this means with these interval angles that I have, if I multiply them by 2, I am again going to have the axes values as 0, 90, 180, 270 and 360 degrees. So this means that if I have my sine of 2x, then sine of 2x shall be for 0 degrees, then this is going to be a 1, and then it's going to be a 0, and then a -1, and then a 0 again. So now if I sketch this graph, so sketching the graph, I will be having on my x-axis and y-axis. On the x-axis, I will be having a 45 degrees, a 90 degrees, 135 degrees, and 180 degrees. So this is going to be my first cycle. Then for the second cycle, I can be having 180 plus 45 giving me a 225 degrees, plus 45 giving me a 270 degrees, and then it's a 315 degrees, and then finally a 360 degrees here. So again, I can see that these are all the intervals of 45 degrees here, which when multiplied by 2 will again give me the axes values as 0, 90, 180, 270 and 360 degrees. 2 times 25, so 2 times 25 will give me a 5 a 450 degrees. 2 times 270 will give me a 540 degrees. 2 times 315 shall give me 2 times 315, this then shall give me a 630 degrees, and 2 times 360 shall give me a 720 degrees here. So if I sketch the graph for y equals sine 2x in the interval of 45 degrees, I have seen that 0 times 0, it's a sine 0 giving us a 0, 2 times 45 was a 90 giving us a 1, then sine of 2 times 90 was 180 giving us a 0, 2 times 135 was a 270 giving us sine of 270 as negative 1, and 2 times 180 was a 360 giving us sine of 360 degrees as a 0 value. So this is the first cycle that we can have for the sine 2x function, and then the same cycle gets repeated again for the second cycle, again in the interval of 45 degrees. So 180 plus 45 giving us a 225, 225 plus 45 giving us a 270, 270 plus 45, 315, and then that plus 45 giving us a 360 degrees here. So this is how the two cycles are plotted within 0 to 360 degrees here. So let's discuss the third case here. The third case is when we have the graph of y equals sine of x plus c. So this is going to be the third case where an angle is added to the value of x. And we know that sine has a period of 360 degrees, meaning the complete rotation for sine is 360 degrees. Now this is going to be the translation of y equals sine of x by negative c and 0, meaning it should get translated along the x-axis by negative c, and no translation with respect to the y-axis here. And the range for y shall be equal to negative 1 till 1. Negative 1 lesser or equal to y, which shall be lesser or equal to 1 here. This is going to be the range of y. So what we see here is that we have the basic sine graph in blue. We have this as the basic sine graph in blue, for which sine of 0 is a 0, sine of 90 is a 1, sine of 180 is a 0, 270 a minus 1, and 360 a 0 here. But then if we have sine of x plus c, then what I can see here is that all the values of sine of x, they are just getting translated horizontally by minus c, meaning sine of 90 minus 90 will get translated with respect to this value here, which is a 0, and this is how the graph shall be getting translated here with respect to the c values. We can see sine of 90 was 1 over here, but after sine of x plus c, it has been translated backwards, and this is my sine of 90 now. Sine of 180 actually here, but then with x plus c, it has been getting translated by minus c. 270 was here, after translation by minus c, it's somewhere here. 360 was this point, and after translation, I can see from here it has gotten translated to this point, which is over here now. So let's do an example to understand the concept more. Sketch y equals sine of theta plus pi by 2. Now my c value here is a pi by 2. So the c value here, it's being a pi by 2. Therefore, I know that this is going to be the translation. The first thing that I know according to the question is that this is the translation along the x-axis by negative pi by 2 and a 0. It's negative pi by 2 and a 0 here. So negative pi by 2 and a 0. So what we can see here is that originally we have sine of 0 as 0, sine of pi by 2 is a 1, sine of pi is a 0, sine of 3 pi by 2 is a negative 1, and sine of 2 pi is a 0. So what I have seen here is that if I need to sketch it from negative 2 pi till 2 pi, then sine of pi by 2 should go backwards by negative pi by 2. That means it should now be translated backward to 0 degrees. So I can see that this is this is my point at 0 degrees here. Sine of pi minus pi by 2 translated again, so it should be over here. 3 pi by 2 minus pi to pi, therefore this point lies here. 2 pi minus pi gives me a 3 pi by 2, therefore this point, which was actually a 0, has now been translated to this point. So over here, what I can see is that if I join all the points, here, then basically this is going to be 2 pi translated backward to 3 pi by 2, pi translated backward to pi by 2, pi by 2 translated backward to 0. So this is my value here, and then it's a value which lies to negative pi by 2, and then a negative pi, and then it should be a negative 3 pi by 2, and then a negative 2 pi. So this is then going to be this graph of y equals sine of theta plus pi by 2. The other way of doing this question is just translate theta by all the values, the angle values that you can have. Like I have done this example with respect to 2 pi, negative 2 pi that lies here. I've substituted theta with a negative 2 pi. So negative 2 pi plus pi by 2. That gives me a negative 3 pi by 2. Therefore, sine of negative 3 pi by 2, negative 3 pi by 2 here. Sine of negative 3 pi by 2 here, we know that negative angle means we have to move in the clockwise direction. Negative angle means we have to move in the clockwise direction. Therefore, negative 3 pi by 2 lies here. And in the anti-clockwise direction, it's a positive pi by 2. And we have already discussed that the angle values with respect to clockwise and anti-clockwise trigonometric function should give us the same angle value. Therefore, if sine negative 3 pi by 2 shall be equal to sine pi by 2, and this here shall be equal to a positive 1. So therefore, it's sine of negative 2 pi, sine of negative 2 pi, negative 2 pi, with theta is negative 2 pi, I should be getting a positive 1 here, and I can see that my graph is just translated backwards, and now this is how the graph is going to be, with this as my first cycle of the graph. This is going to be the first cycle of my graph here. I can just continue because I have to make it up till 2 pi, so I can just carry on with it, and I can just join this point over here. So this is how the graph of y equals sine of theta plus pi by 2 needs to be drawn. So let's discuss the fourth case. So the fourth case is for y equals sine of x plus d. So y equals sine of x plus d, we know that sine has a period of 360 degrees. So what happens here is that we can see the constant added to the sine function. It's sine of x and then a constant added here, plus d. Therefore, I can say it's the translation of y equals sine x by 0 and d, meaning it's the translation along the y axis. And the range of values of y equals sine of x plus d shall be negative 1 plus d, negative 1 and a plus d, lesser or equal to y, which shall be lesser or equal to 1 plus d over here. So this is how the translation of this y equals sine of x plus d takes place. So let's do an example. Let's sketch y equals sine of x plus 2 for 0 degrees lesser or equal to x lesser or equal to 360 degrees. So here I can see that a plus 2 has been added to the sine function. Therefore, it's a translation along y-axis by factor, which is a 2. Translation 0 and 2. So if I just sketch the basic graph of the sine function, then what I can see here is that the range of the graph, according to the question, that the range here shall be equal to negative 1 plus 2 lesser or equal to y, which shall be lesser or equal to 1 plus 2, or I can say that this range is from positive 1 lesser or equal to y till lesser or equal to 3 here. So I shall be having a 0, 90 and a 180, and then it's a 270, and then it's a 360 here. So if I just sketch the basic graph, then the basic graph over here is having the range from -1 till +1 here. -1 till +1 here. And now the range that we have says that it should be from 1 up till 3. So let's have it in a different color. It should be from 1 up till 3. So over here, what I can see is, so to sketch the graph, I have made a dotted line here with respect to the 2. So this dotted line here is actually going to be the mid-axis. So always remember, the constant in the equation is always going to be the mid-axis, and the coefficient of the sine function is going to be the amplitude of the function. So this means if you are given y equals sine of x plus 2, then basically this is going to be the mid-axis of this graph, and the coefficient here, which now in this case is a 1. Sine of x means it has the coefficient which is a 1, and this then here is going to be the amplitude. So if I need to sketch the graph, there are a few things to remember. Number one, the constant in the graph, in the equation, has to be the mid-axis, and the coefficient of the sine function needs to be the amplitude here. So if that is the case, then in this question, in this equation, +2 is actually the mid-axis. I have made it with the dotted line, and 1 needs to be the amplitude, meaning this value here, it's going to be a 2 plus 1. That should give me the maximum value, which is going to be 3. And we have 2 minus 1, which is giving us a 1, and this is going to be the minimum value of the graph here. So this is another way of finding out the range of the graph, and the range of the graph, as we have seen earlier also, is from 1 lesser or equal to y lesser or equal to 3. So another way of finding the range of this graph, of this equation, is to add the mid-axis value, the constant, plus the coefficient of the trigonometric function, and subtract to get the maximum or the minimum value. So this will give us the maximum or the minimum value on the graph here. This is another way of solving this question. So now what I can see here is that this graph shall only be getting translated by 2 units. Therefore, it means that if at sine of 0, if this is the initial original graph of y equals sine of x, they will just be getting translated upwards by +2. Therefore, from 0, sine of 0 was a 0, it shall be getting translated to a +2 here. 90 was a 1, so 1 plus 2, that gives me a 3. 180 was a 0, so it should give me a 0 plus 2, that gives me a 2 here. 270 was a -1, so -1 translated by 2 units gives me a 1, and 360 was a 0. Translated upwards by 2 units, from 0 plus 2, it shall be going up till 2 over there. And this is how I will be obtaining the graph for y equals sine of x plus 2 here. Sine of x plus 2 here. This is my graph for y equals sine of x plus 2. So what I can see here is that it's the graph which has just been translated upwards by 2 units, and we do have the maximum and the minimum value, meaning the range of the graph. And to find the range of the graph, we have two methods. Number one, to -1 add the constant 2, and to +1 add the constant 2, giving us the range from 1 lesser or equal to y lesser or equal to 3. And another thing that we have discussed here is that the constant in the equation is actually the mid-axis. Mid-axis, that means from the mid-axis I should be having the amplitude or the height of the graph upwards, above the mid-axis or below the mid-axis, and this amplitude is actually the coefficient of the sine or the trigonometric function. In this case, it's a 1. Therefore, it means from the mid-axis, it should be 2 plus 1, giving us a 3. This is the maximum value. On the y-axis, 2 minus 1, giving us a 1, which is the minimum value on the y-axis. And we can see that the range by both the methods is the same from 1 till 3 here. So this is how I shall be obtaining the graph over here. So these are the cases that individual cases that we can have for all the trigonometric functions. So in the end, if I combine all the properties, then what I can say here is, if I combine all the four cases, then y equals a sine bx plus c plus d, where we should know that a is the amplitude. The coefficient of the trigonometric function is actually the amplitude. B is the stretch parallel to the x-axis by factor 1 by b. C is the translation along the x-axis so that it can be given by the matrix negative C0. And D is the mid-axis value. Also, it's the translation along the y-axis with 0 and D. So this is the basics of our trigonometric function graphs. And so let's solve this question from summer 2014, paper 1, variant 1, and it is question number 1. The sketch, the graph of y equals a plus b sine of x is given, and the question says the diagram shows part of the graph of y equals a plus b sine of x. State the values of the constants a and b. So state the values of the constants a and b here. So if I am given y equals a plus b sine of x, so first thing is to understand what our a and what our b is going to be. So we know that this a, it means it is the mid-axis value. It is the mid-axis value, and this b is actually should be the amplitude. Amplitude means from the mid-axis value, it should be the height of the graph. So another thing that I note here is that it's a 0 degrees, sine of 0, that is giving me a 1 value. Sine of pi by 2, it should be a 1, but now instead of 1, it has been taken up till 3. And sine of 3 pi by 2, which is actually a negative 1, is basically a negative 1 in the graph over here. So what actually has happened, as sine of pi should be a 0 is now at 1. So let's see what the question suggests and how we shall be doing it. According to the graph that we have, what we can see here is that the minimum value of the graph is a negative 1 and the maximum value here is a 3. Minimum is a negative 1 and the maximum here is a 3. Therefore, the mid-axis value has to be between negative 1 and 3. So let's start working on the graph quickly. It's just a 2-mark question and needs just understanding to complete the work. So we have the range of the graph, which is from negative 1 lesser or equal to y, which is lesser or equal to 3. This is the actual range of the graph. So to get the mid-axis value, I should say it's a 3 and negative 1 added to it divided by 2. So this value gives me the answer as 2 by 2, which is a 1. So what I can see here is that the mid-axis value for the graph is actually a positive 1 here. From here, another thing that I note is that the amplitude, the maximum value on the graph is a 3 and the mid-axis value is a 1. And from 1 up till the minimum value, which is a negative 1 lies here. It's the minimum value of the graph. Positive 3 lies here. It's the maximum value on the graph. So from the mid-axis, I can see that the amplitude on both the sides, above the mid-axis and below the mid-axis, it's a 2 unit. So over here, this 2 unit, the amplitude has to be our B. The amplitude, we know that B is the amplitude. So this B needs to be the amplitude. A, which is actually the mid-axis, or we can also say that it's the translation along the y-axis, which we can see that the translation along the y-axis is going to be a 1, and the mid-axis value is also a 1. Translation, sine of 0 is a 0, translated to 1. Translation, and the mid-axis value, that is also equal to a 1. So here quickly I can say that y then shall be equal to a, the mid-axis value, which is a 1, b is the amplitude, which is a 2, and then it's a sine of x. So we can say that this b is actually the amplitude, or it's the stretch along the y-axis parallel to the y-axis by the factor, which is a 2 in this case. Therefore, this is how this graph needs to get completed. So if I just check the values with respect to x as pi by 2, let's check it for x equals a pi by 2. So if x is a pi by 2, our y value should be 1 plus 2 sine pi by 2. So y equals 1 plus 2 times sine pi by 2 is a 1. So I can see that it's a composite graph with the translation along the y-axis as well as a stretch in the y direction, giving us the y value as a 3 when my x is going to be a pi by 2. So x is a pi by 2, x is a pi by 2, and I can see that the value that is given on the curve is a 3 here. So this is how such questions need to be done just by understanding. So I'm again repeating, the constant in the equation is actually the mid-axis. So we got the mid-axis with respect to the maximum and the minimum values on the graph. Maximum value was a 3, minimum value a negative 1. So I took the mid value for both of them to get the mid-axis value. So the mid-axis value was 3 plus negative 1. I have added both the extreme values and divided it by 2 to get the mid value here, or the mid-axis value here. 3 minus 1 is a 2 divided by 2, that gives me a 1. Therefore, this one is actually the mid-axis, and with respect to the mid-axis, I just got the highest point, which was at 3. So 3 minus 1 give us the amplitude of 2. I got the minimum point on the graph, which was a negative 1. So 1 till negative 1, again I can see that it is 2 units downwards, 2 units upwards from the mid-axis. Therefore, the amplitude here is a 2, or I can say it's the translation along the y-axis, which is a 2, and b, which is the stretch parallel to the y-axis with the stretch factor. So with the stretch factor, which was equal to a 2 here. So this is how I shall be getting the values of a as well as b. So y is equals to 1 plus 2 sine of x. So this gives me the answer here. The next question that I've chosen to explain the concept is from February March 2018, and it's question paper 1 variant 2, and it's part B of question number 5. It's question 5 part B. And in this question, they have given us the graph when x is a 0, when the theta value is a 0, the y value is a 2, and we have the maximum value, and then it's 150 degrees, giving us the theta value as a 0. Then we have another value here giving us the minimum value, and then this is how the graph continues. It's for y equals k sine theta plus alpha. The diagram shows part of the graph y equals k times sine theta plus alpha, where k and alpha are constants, and 0 degrees is less than alpha less than 180 degrees, meaning alpha has to be between 0 and 180 degrees here. So we need to find the value of alpha and the value of k. So we can see that y equals k sine theta plus alpha. There are two transformations that are taking place here. Number one, it's the k, and number two, we have the transformation, which is plus alpha. So what k is? K is the stretch parallel to the y-axis with the stretch factor 2. So obviously we can see that originally sine has to be between negative 1 and 1, but then it has been stretched to the value which is even greater than 2, and then less, obviously has to be less than negative 1. And then it is also translated by alpha, and in this case this alpha here, theta plus alpha, is the translation along the x-axis by negative alpha and 0. Now we are supposed to get the values of this k and this alpha. So if we just look at the graph, what we know is that this graph has been translated along the x-axis backwards, negative alpha. It has been translated by negative alpha, and we know that in the original graph our sine of 180 is actually a zero, gives us a zero value. We know sine of 180 degrees actually gives us a zero value, but in this given graph it's sine of 150 degrees, which is giving us the value which is a zero. It's on the graph. Therefore, what we can say here is that the graph has been translated by, we can say that this graph has been translated by negative 30 degrees, which comes from 180 degrees minus 150 degrees along the x-axis. Along the x-axis here, this negative 30 is the difference between 150 and 180, and then it should be a negative 30 degrees along the x-axis, meaning it should be negative 30 degrees and a 0 here. So we got this alpha value, which is going to be a negative 30 degrees. Now to find the value of k, another information that we have in this question is regarding sine of 0. When our theta value is a 0, the y value is a 2 here. So y equals k sine theta plus alpha. We have decided that alpha needs to be a 30 degrees here. So if this is a 30 degrees, then y equals k sine of theta plus alpha. And in this diagram, we have seen that for sine of 0, the y value is a 2. Therefore, this means that if our theta is a 0, the y value needs to be a 2. So I can substitute all the values. I have my alpha also. So I can say it's 2, which is equals to k sine of 0 plus 30 degrees. Or I can say it's 2, which is equals to k sine of 30 degrees, and sine of 30 degrees then is equals to 1 over 2, or I can say that this k value needs to be a 4 here. So k is equals to a 4, alpha equals 30 degrees, and this is what the question was asking us for. Therefore, in the end, I can simply say that it's alpha, which is a 30 degrees, and k value, which should be equal to a 4. That means it's the stretch, which should be equal to a 4 over here. So this is how this question needs to be done. And so let's do one more question regarding the same concept. And this is from Winter 2017, paper 1, variant 1. And it is question 7, part A. The graph has been given to us. And according to the graph, they are saying it's the diagram which shows part of the graph of y equals a plus b sine of x. It's this curve representing y equals a plus b sine x. So we are supposed to find the values of the constants a and b here. So what is given in the graph is that it's the y-intercept here, meaning when the angle is a 0, the y value is a negative 2, and we have this maximum value on the graph, which is a 1. So again, it's the same very easy concept that we should be following. It's y is equals to a plus b sine of x, where we know that b has to be the amplitude or the stretch along the y-axis, and a has to be the mid-axis value, or it's going to be the translation along the y-axis here. So in this case, what I can see here is that when our x needs to be 0, the y value is giving a negative 2. When x is a 0, the y value here is giving a negative 2. So x as 0, what I can say here is that substituting negative 2, which is equals to a plus b sine of 0. So obviously sine of 0 is 0. My b gets eliminated, and therefore I can say that a value here is a negative 2. So I have the a value, which is a negative 2. So a here, after getting the a value, which is a negative 2, the next thing that I should be knowing is that the maximum value here is a positive 1. Therefore, I can get the amplitude, which is actually the coefficient of sine of x. So from 1 till 2, I can see that the amplitude from 1 till 2 is going to be a 3 unit, the amplitude that needs to be a 3 unit. Therefore, I can say that the b value here is a 3 unit, and I can very easily say that the final answer is a equals minus 2 and b is equals to 3 unit here. So this is how, again, this question needs to get solved. So let's meet you in the next video for the cosine graphs and more questions from past papers. So till then, best of luck and enjoy. Okay, thanks for watching. Allah Hafiz.